sequence where we just set it as there was some common rate, where your nth term was your first term times your rate to the n minus 1. And when you had a list of numbers, it was to figure out the rate, it was just to take consecutive terms and divide them out to figure out what the multiplier was, whether it was a whole number, a division problem, multiplying by a fraction. Or if there's a positive or negative thrown in there. So my guess is that when you're walking through and you're solving and setting up for nth terms, where your first term is 3, your rate is 2, it's a matter of just direct substitution. The nth rule would be first term times the rate to the n minus 1, and you'd go from there. If you were to use your tape, it's just rehashing a little bit of the ninth group from Day? Yes. Tuesday. We started a little. When's Monday? Remember we started a little bit on Monday, right before the quiz? And then Tuesday was the quiz. Yesterday I had a sick kid. Today's Thursday, so we go through it this one. Writing them out when you know first term and the rate, it's really, 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 really easy. The 15th term, so we're trying to find the 15th term, which would be your first term times the rate to the 15 minus 1. Well, if you know your first term is 20 and their common ratio is 1.05, again, calculator, 20 times 1.05 to the 14th power. One way to, a lot of times people do the geometric stuff is they'll accidentally put the first term and rate in parentheses. Don't do that. Bad things. So just be careful when you type in the calculator. What? Hey, buddy! I heard that earlier. I'm like, oh yeah, it's that or I'm wearing a picnic mask.
I think you look right.
I'll just look at that. It is. Hey, good luck. Thanks, you too. Thank you.
What is he doing?
Being the student. So, wandering around aimlessly passing out passes and, stealing money from smaller children. That's what you're
Right, that's why I
That's
that's
not
what he
nice.
said.
Yeah.
Be careful, it's
Oh no, I don't know what my rate is. What do I do?
Not mine.
We already did this.
I know, I'm just making sure. Remember, so the first term, what's your rate?
3.
If I want to find the 12th term, what is my value of n?
11.
So it'd be 12 minus 1. And then you just do that. This is just rehashing what we did the other day, so this should be really, hopefully, okay. So let's look at the weird stuff when you have just, I got this out of sequence, excuse me. When things get a little weird. Let's write the rule for the nth term. We have 2 terms in the sequence where one of them, the second term is 45, and the 5th one is negative 1, 2, 1, 5. Let's write the rule for the geometric. So for each time you have something like this where you're given 2 different points in a sequence, it has to tell you whether it's going to be geometric or arithmetic. There's no other way around it. You're not going to be able to figure it out if you don't know that. So don't worry, you're not going to have to decipher on your own whether it's going to be arithmetic or geometric. It'll tell you specifically which one to work with. So since what we have now, we know that the second term is 45, the 5th term is negative 1, 12, 15. We're going to set it up as and write them independently as an nth rule. So your nth rule is your first term rate to the n minus 1. and fill in the blanks of what you know. I know that the second term is first term plus, or times r to the n 2 minus 1. What is the second term? 45. So if the second term is 45, this is the first term times rate to the first power. I do the exact same thing with the fifth term. I know that I have the fifth term is the first term times the rate to the 5 minus 1. What is the fifth term? Negative 1215. When we had this problem with arithmetic, we did it as a system of equations. We kind of do the exact same thing here, but we're not going to use an elimination method. We're going to use substitution. So we're going to substitute in. What I want to do is rewrite the first equation in terms of the first term, which means I'm going to get the first term by itself. And I do that by dividing by r. So 45 over r to the first is my first term. And now what do I do with that? Substitute it to the other side. I'm going to take this here. And I wind up with negative 1215 is 45 over r to the first times r to the fourth. And what's that? We might have. Well, good. That means you remembered something. Yay! What's r to the fourth over r to the first? R to the third.
Wow, sorry.
So I have negative 1215 is 45r cubed. And to solve for r, what do you do? Divide by 45 and take the cube root. It's either, well, we took a cube root of a negative, so would it be 3 or negative 3? Negative 3. What's that?
Oh, I didn't do it.
That's your problem. Okay. So now I know that my rate is negative 3. How do I figure out my first term? Let's go back here again. So your first term is negative 15. Your rate is negative 3. Your nth rule. Nth rules. So there's your answer.
Do you ever get an itch right in the middle of the bottom?
Yeah.
It's like take off your shoe and then you have to scream.
That happens to me, Sydney.
No, it's stinging. That's the worst.
You have to like take your whole shoe off and then like,
It's
and
when,
you,
when you're wearing like jeans that are really tight.
oh yeah, you try to-
It's like right in the middle of your leg and you can't.
Oh, I thought like worried about your foot. Like, how does that have to do?
Well, like I could understand how the jeans, because you can't like lift your leg, you know, to take your shoes off. That happened to me yesterday.
You're driving.
Driving in watches is really hard.
Driving in heels in general is really hard.
Yeah,
It's terrible. I just take off my shoes.
Yeah, it's hard.
At least you're not texting.
Just a tad.
I have a feeling next time I say something like that, I turn around, she's just gonna flip me off, so. Do the same thing here, see if you can figure this one out. A little trick here, guys. Whenever you're writing out an nth rule for a geometric, and you have the two equations, usually you want to take and get the first term by itself. It's much easier than anything else because you can isolate that in both of them because that remains constant between both terms. So don't forget that. And then the same thing over here, the fourth term. First term, r to the 4 minus 1, so it is 1/5. First term, r cubed. So 1/5 is 5 over r squared, or r cubed, excuse me. And for geometry, you get 1/25 is r squared. Therefore, your rate is 1/5. So if your rate is 1/5, what's 5 divided by a fifth? 25. So your nth rule would be 25 times 1/5 to the n minus 1. And the other thing that's nice, 1/5.
What did I do?
I'm not.
She hit me.
Tessa hit me.
You've been abusing me the last 2
Tessa hit
days.
Are you okay?
No, I'm not. I have bruises all over.
me. He does not.
How do you know?
Let's look at sequence.
That hard, I'm not that strong.
Oh, I'm sorry, series. Series. This is what we haven't done yet. The series for geometric. Yes, ma'am.
I've never mind, this might be answering. Yeah, it does. Well, actually, it doesn't.
The sum of the series for a geometric is the formula. First term, 1 minus r to the n over 1 minus r. This is the same thing as saying the sum as, we'll say x starts at 1 through some value of n. Excuse me. Of your first term, r to the x minus 1, however many times. You're just adding all of them up so many times. First term in the sequence, second term, so on and so forth. The trick with the sum of the series is that, again, you're probably going to want to write out the rule. No, I'm sorry. I'm thinking of the other one. The sum of the series is going to be really fast. What's going to be the weird part is when we try to figure out the value of n to add up to equal something when we solve for n. Just like we did with arithmetic, we had to do a system of equations with that one. And this one, we're going to wind up doing regular substitute stuff in, but yet in the end, we don't need a table to figure it out. We're going to take a logarithm. They mean the same thing. This is the more traditional workable one. I would worry about that one. But this means the same thing. Okay, they mean the same thing. It's just that the one with s sub n is just the more workable equation. So let me show you an example with the workable equation, how this goes through. Find the sum. Got a sequence here. Let's take the series 1 plus 5 plus 25 plus 125 plus 625, and let's find the sum of the first 10. Sometimes they might call it the 10th finite sum. Oh, partial sum. Thank you. I forgot what it's called. Yeah, 10th partial sum. So I want to find the sum of the first 10 terms. So I want to find the sum of 10 of them. Well, sum of 10 of them is going to be the first term. I'm sorry, n, first term plus the n. I forgot the formula all of a sudden really fast. My mind went blank. 1 minus r. Excuse me, I get these mixed up. So we got to figure out our rate. What's our rate in this case? Times 5. Good. The rate here is going to be times 5 because I take 5 divided by 1, 25 divided by 5, 125 divided by 25, and so on and so forth. So our n is going to be 10. Our rate is 5. We substitute in. If I put that in my calculator, I just have to make sure I use parentheses and a fraction bar, and just go from there. Thanks, sir.
That's a good one.
What are you getting? I bet you it ends in 5.
Or 0.
Or a
Mine
0.
actually
Okay.
didn't end
End
in
with
5.
0. That's why I was like, maybe it's wrong for this end in 5.
It doesn't end in
But-
5 words.
Oh yeah, it wouldn't because it's gonna because you have the plus 1. So it could end in a 6 or a 1.
Oh, there you go.
2, 4, 4, 1, 4, 6, 0.
Yeah, that's fine.
I got a 2, 4, 4, 1, 4,
Yeah,
0,
it's
6.
supposed to be a 1 in front.
What?
Yeah, I put it in right.
What did I
change?
A1.
Oh, I put the pence in first term. I'm sorry.
Oh.
Oh.
You were right.
Thank you, Chairman, for having faith in me.
No problem.
Oh, wait,
Okay,
I
well,
put
I
a 1
just
there.
saw
That's right. But I typed it in wrong. Look, it's on my paper as a 1.
What is it?
No,
So
you're
you're
right,
right,
it is
441,406.
Say that slower.
Oh, so it's the same thing.
406.
Gosh, darn it.
No, there's,
There's a 1.
2, 4, 1.
no, 2.
No, 4, 4.
Yeah, 2, 4, 4, 1.
406.
So you wanna look at it?
406.
That's right.
Yeah.
Yay, clever review. I'm happy for you. Fantastic.
Awful rotten that day.
But I do know what love is.
I will. Last time we were, I will throw this at you guys.
Oh my gosh. Get out.
I've never seen Forrest Gump.
What?
Wow.
What?
I've never
Yeah,
seen
I'm
that.
getting that honor.
I don't need to see Forrest Gump to see a live.
I did not see Forrest Gump.
Honestly, I saw it for the first time.
Yeah, thanks, Tessa.
She's still solid.
I have no idea what happens. All I know is he talks about some chocolate at some point.
Oh my gosh.
Oh my god.
It's a metaphor.
I think so. Ian tried that.
Did I write down the formula correctly?
Yeah. Yeah.
No.
Find n such that the sum of them adds up to 3906, which basically means how many do I have to add up to equal 3906? So we knew that the first term was 1, our rate was
Oh,
5.
same thing. Okay.
Yeah, it was the same, this is part B of that. So in this case here, I substituted in what we know. Well, find the sum of however many is first term, 1 minus our rate to the n over 1 minus our rate. We want it to equal 3906 is 1 times 1 minus 5 to the n over negative 4. What do you do first?
Just by
Multiply by the negative 4. Get rid of the denominator. Multiply by negative 4. So if we do that, we get a 4, 2, 15, 6, 24 negative
Yeah.
is 1 minus 5 to the n. I need to switch that negative 5 to the n to become positive, and then I'm going to move these 15, 6, 24 to the right to also make it positive. So I get 5 to the n is 15, 6, 25. And now, how do we get exponents to fall? Log base. Log base what?
5.
Log base 5.
Yeah.
So you take log base 5 on both sides.
Where's the log?
Where is it?
It's right above the 10 to the power.
Is that where it is on that one?
Yeah, I'm appreciate that's what
You were spazzing and everything just fell.
It's taking forever to boot up. It's Control 10 to the X, I think is where you change it out on these.
Yeah.
Yeah, whatever. What'd you get?
I got 6.
So this one, when you're trying to solve for n with geometric, it's a lot less work than it was solving for n in arithmetic. You don't have to worry about the system of equations. You don't have to worry about distributing and combining like terms. Here you're just moving things around and taking a log base. Right? Do another one like that?
Sure, Mr. Murphy. You can try another one.
All right. Find the sum of 10 of them. And then when you're done, figure out how many you have to add together. Get 820.
I can't help but feel like the answer's going to be lower.
Wait, okay, how do you find the sum of a
Yeah, I'm gonna
infinite
print on that one.
one?
That equals 4.
Oh yeah. That's a little too easy, isn't it?
Yeah.
What?
Yeah, it's beautiful.
But
This
it's
plus.
at 1. No.
What's 1 plus 9? What's 10 plus 81?
It's, so that's.
What's 91 and 729? So let's say this wasn't just that easy. Let's say you had to work through it the long way. Let's see how we would do that.
But we don't.
Well, do we really need to figure out how to work through it?
Well, I'll just show you guys how to set it up again. It doesn't hurt.
Yeah,
Mine first.
So find the sum of 10. First term, 1 minus the rate to the n over 1 minus the rate. So the sum of 10 of them is 1 times 1 minus, what's our rate? 9 to the 10th power, or 1 minus 9. So the sum of 10 of them is how many? A lot. Good answer. $435,848,050. Do you need me to walk you through the other ones? I guess you do. This should. What's that?
Wait, is there more?
Please excuse the interruption. Can I please have Isabel Osborne, Garrison Tad, and Angel Corral to the forum room, please? Isabel Osborne, Garrison Tad, and Angel Corral to the forum room, please.
What's that? infinite series. We have infinite series. What happens with an infinite series?
Gosh.
What happens with an infinite series? You're right. There is no infinity button on the calculator, just like there wasn't last year. There's another formula for this. What happens as n grows larger and larger and larger? 1 minus that is approaching 0. I'm sorry. R to the n is the rate's approaching 0. So as it's getting closer to infinity, so that's why we say there's an infinite sum as things keep going and going and going. So you wind up with this generic formula. Oh, the sum one? Thought it was under. So you wind up with this, where you have the sum of an infinite.
It's actually.
It's not.
That one, or it's.
No, it does something, it just is unable to compute.
Help him with what? Mr. Mercury, I think there's a summation bar.
Yeah, where's it again?
Next to the 9.
What's that?
Next to the 9, it'll flip over this.
Oh, thank you. I don't know why I was trying to brain fart. So what happens here is that this is going to be your first term over 1 minus your rate. That's how you find the sum. So the pre-calc book writes it a little bit differently than what you guys saw last year. Right. So this one here, this book shows it. Let me write it out the way they did it. So, but in order for this to work, our rate value, the absolute value of our R value has to be less than 1 in order for it to work. If the rate is greater than 1, you won't have a sum of an infinite. Okay. That's why this has to work like that. Okay. The R value, the rate has to be less, the absolute value of it has to be less than 1. Okay. So what you'll see is, like you were saying, you had the sum of the infinite series where it was I equals 0 to infinity. First term of 4 times 0.6 to the whatever, how did they write it? To the n minus 1. All that winds up being then, or actually this one would be n because this starts at 1. What's your first term? 4. What's your rate? 0.6. So that means it winds up being 4 over 1 minus 0.6. And that'll tell you what the sum is as it's approaching infinity, how much is it adding up to equal. That's all that is. Remember, if your R value winds up being greater than 1, the absolute value is greater than 1, it doesn't have a sum. It won't work. That's really the only rule that you have.
Go right in the grade book.
It's not good.
Yep.
Transcripts, exactly.
Take 1 point off of her request.
I was like,
That's
doing-
how you do infinite sums. The only rule is that you have to have the weight value the absolute value has to be less than 1. If it's greater than 1, won't work. That's it. You should be able to knock out the rest of the stuff.
Okay,
Yeah.
Whatever's on that sheet, finish out, you should be able to finish out all that. I also had,
What made you think?
I also had a couple more of those sum
I don't know,
questions.
is it? If it was, I'd be saving you.
It's got some more sum problems.
Why? It's too much.
Yeah, study for everything.
Wait, is this more homework?
Literally everything. Like I have to read the entire history book today.
You aren't gonna do any of it.
Yeah,
Yeah.
obviously, like I said, I will not be around
I
tomorrow.
know the.
This will, all of 93 will be due on Monday,
And I
including
know the
these.
Renaissance, and then
Oh,
I
so-
don't know anymore.
I'm not so much doing
Oh,
more.
sweet, so I'm
And then I know from the from Reformation. I don't know anything from the Reformation. Yeah, no, I know the